us to another episode on ASUG 12 exams. So in this episode we are looking at the 2021 Science Paper 2. So this is basically chemistry. So let us move straight to section A, which carries 20 marks out of 85. So straight to question 1. Which of the following is not a laboratory law? So A, do not write on the board. B, do not eat while in the laboratory. C, always put on closed shoes. D, always close gas taps. So basically D is correct. Always put on closed shoes, correct. Do not eat while in the laboratory, correct. So A, do not write on the board. Writing on the board is allowed when you're doing your experiment. So A is the one which is not a laboratory law. Number 2, a learner accidentally mixed ammonium chloride and common salt. What method would you use to separate the mixture? So basically we know that ammonium chloride is one of the 4 substances that are basically sublime. So 1, we have iodine crystals. Then 2, we have ammonium sulfate as the other one. Then the number 3, we have a carbon dioxide, which is also known as a dry ice. So in addition to the ammonium chloride, so all these they sublime. So because ammonium chloride is sublime, then we have a common salt. So how can we separate the mixture? We can do sublimation. Sublimation would be the best method to separate ammonium chloride from a common salt. So what we do is basically we just eat the mixture in the china bowl covered with a funnel. Then basically ammonium chloride will evaporate. So when it evaporates, it will stick to the wall of the funnel. Then the salt would remain in the china bowl. So we can separate those after just cooling. So D is the best answer. We move to question 3. The results of a paper chromatography experiment are shown in the chromatogram below. X is an aqueous solution of a salt of group 1 element. Then Y is an aqueous solution of a salt of a transition element. So which law is correct? So we start with the large retention factor, which is this one. So a retention factor, let me just write RF. So RF is given by the distance moved by the spot. You divide it by distance moved by the solvent. So this ratio is what is known as a retention factor. So now the distance moved by the solvent is from here to here. Because the solvent will be here, then this will be the starting line for the solvent. Then if you see Y, this is the spot, this is the distance. So this distance, if you put it here, find this one, put it on top here, it will be greater than if you use this distance. So the one with the large retention factor would be basically Y. So anything with X out. Then requires locating agent. So which one would require locating agents? So if you know X is a salt of group 1 element. So salts of group 1 elements are normally colorless. Okay, they are normally colorless. because why are they colorless? Okay, because these are diamagnetic, okay, and they do not have impaired electrons. So because of that, they are colorless in nature. So because they are colorless in nature, these salts formed from alkalis, so alkali salts are normally colorless in nature. What it means is to locate this would need a locating agent, because there is no color, you can see. So we need to a locating agent, hence X should require locating agent. As you will notice, transition elements metals, these they are color in nature. Most of the salts that are formed by these transition metal or earth metal, they are colored in nature. So these are easy to locate. So hence A should be the best answer here. Question 4. The following diagram is a cooling curve of gas. What process occurs at stage V? Stage V. So what we know is, in this case here we have this is the gas itself. Then at V we have gas and the liquid. Okay. Then here we have basically a liquid itself alone. Then at W we have liquid and the solid. Then here we have basically just the solid. So the question is, what process occurs at V? So at V the gas is turning into liquid, so that should be condensation. Okay, condensation. Number 5, from the table below, which one is an ion? Okay, so which one is an ion? So basically an ion is an atom carrying a positive charge, okay, due to the loss or gain of electrons. Okay, so now what we need to see is we need to see the one that has protons and electrons are not equal. That one will carry an ion, okay, will carry a charge. So this is 12 correct, so A is okay. 12, this is okay also. We have 16, 18, 20. So what you notice here is this one is the only one which is imbalanced. So C would do ideally be the correct answer, because we have lost, we have gained more electrons, such that we have more electrons than protons. So this one has a negative charge, which is an ion. So that is the case. Okay, let us move to question 6. Magnesium chloride has a high melting point. It is used to line the inside of furnaces that operate at high temperature. This is because, okay, has strong forces between its molecules. It is a simple molecular substance. C as a metallic bond. D is ionic compound. So what you know is this is basically made up of magnesium and the oxygen. Magnesium and the oxygen, that's the compound. So this one is not metallic bond, because this is a metal, this is a non-metallic. So basically the best answer would be D, which is ionic bond, the bond between a metallic and the non-metallic. So D is the best answer. So basically ionic compounds are basically composed of opposite charged ions, and these opposite charged ion, which is they are held by strong attractive forces, which makes them to have high melting point. And this is the case of metallic and non-metallic, which is ionic compound. Number 7, naturally occurring element Y has 4 isotopes whose relative abundance is shown in the table below. Okay, so we have this. Find the relative atomic mass of this element. Okay, so let us find the relative atomic mass. We shall call it R dot A, relative atomic mass. So what we need to do is we need to multiply this is a percentage by this. So we start with basically this is 1.48%, or what we do is over 100%, because remember when you add this with your calculator, since this is percentage, should give us 100%. Okay, so multiply by 204, then plus, we come to this one, which is 23.6%, so over 100, multiply by because we are dividing by 100 to make it a percentage, 206, then plus 22.6 over 100 multiplied by 207, then plus 52.32 over 100 multiplied by this one, which is 208. Okay, once you do that, then we add. We multiply these and add using a calculator. What we are going to find is basically a 207.2428, which is the same as 207.24 to 2 decimal places. Then we come and check here, we find that B is the correct answer. So what is important here is always with this question, multiply this by this percentage, then add their multiplication. Then what we are finding the weighted relative atomic mass. Number 8, the chemical formula of ammonium gas is NH3. Calculate the number of atoms contained in 85 grams of ammonium gas. Okay, so we are asked to find the number of atoms contained in ammonium gas. So basically, when you ask such a question, there are number of atoms. So we shall call it number of atoms contained in a given compound is given by given mass over molar mass of the compound. Then you multiply this by approximately 6.2 multiplied by 10 to the power 23. So when you go back to the periodic table of the exam paper, you find this number. This number is given that these are the number of atoms per mole. So what you need to do is convert this to mole. How many moles are in this? So what we do is basically, so what you need to do is, so the given mass is 85, then over. So when you look at ammonia, is NH3. So if you are to find the number of the molar mass of this nitrogen, the mass number is 14, then plus we have 3 hydrogens, so each hydrogen has 1 mass number, so we have 3. When you add this, we have a 17. So this 17 is basically the molar mass. So here we put 17, then multiply by 6.02 multiplied by 10 to the power 23. So once you do that, what you do is 17 into 85, it will just give you a 5, then 5 multiplied by this this whole thing is just a 5. So your 5 multiplied by 6.02 multiplied by 10 to the power 23, you are going to end up with basically 3.01 multiplied by 10 to the power 24. So if you check here which one is correct here, what you notice here is in this case C is the best answer. So C is the best answer. Question 9. Sodium hydroxide was used to neutralize sulfuric acid as shown in the equation below. How much sodium hydroxide would be used to neutralize 490 tons of sulfuric acid? So the question is asking us to find the amount of sodium hydroxide that would be used with 490 tons of sulfuric acid. So the first step is to ensure that the equation is balanced. Okay, so in this case we've been given the equation is much more easier. So just to confirm, so we say that this is 2 sodium and this is 2 sodium. So ideally this should be balanced because it's a balanced equation that we've been given. Then we have 6 oxygen this side and 2 plus 4, which is 6, so it's a balance. So having known that, we need to look at the mole ratio. So the mole ratio is 2 to 1. So if you are, for every 2 moles of sodium hydroxide, we need 1 mole of sulfuric acid. So the next step is to find the number of moles in 490 tons of sulfuric acid. So the number of moles, we shall call it M, is given by a mass given divided by a molar mass. So the moles of this sulfuric acid that we've been given will be equal to 490 tons. So now these tons should be converted to grams. So there are 1000 grams in 1 kg. Okay, and there are 1000 kg in 1 ton. So we need to multiply 1000 by 1000. So this gives us basically this 490 multiplied by 1 million, which is 1000 by 1000, to convert it to grams. Then we need to find the molar mass of sulfuric acid. So let us go to the periodic table. So we have basically this. So how many hydrogens? There are 2. So the mass number is 2, so it will be 2 times 1, then plus sulfur. So sulfur is here, this is 32, there is only 1, so you see 32 multiplied by 1, then plus oxygen, there are 4. So oxygen is 16, so it will be 16 multiplied by 4. So we have 2 plus 32 plus 64. We are going to end up with 98 grams. So that's the molar mass. So having done that, we can substitute. So this is 98. So 98 into 490, we just end up with basically a 5. So 5 multiplied by this 1 million, we have a 5 multiplied by 10 to the power 6 to reduce on the space. Remember, to the power 6, we know that is a million. So these are the moles that are here. So if these are the moles that are here, we know that if here we have 5 million moles, what should be here? Because it's 2 to 1. So this should be basically 10 million moles. That what should be there. So that's the principle. So we are saying, if here, let me use the lead pen so that you see clearly. So if this is 5, this should be 10 because of, remember they use 2 to 1. This is the 1 in front there. So that should be the case. So now, because it's 2 to 1, the total here should be 10 million moles. So what this tells us is basically 2 sodium hydroxide mass is equal to 5 multiplied by Now 5 is not 5, it's 10. Exactly, this is 10, so we put 10 there, not 5. 10 multiplied by 10, which is 10 million to the power 6 moles. Then we just want to find the exact number there, so we divide by 2. So we have the exact quantity of sodium hydroxide will be basically 5 multiplied by 10 to the power 6 moles. So now these are the moles that are required. Now these moles need to be converted to basically mass. So using this formula, we can find the mass. So we just multiply, cross multiply the number of moles multiplied by the molar mass. So what we need to do is basically now do this. The mass required of sodium hydroxide will be equal to basically number of moles multiplied by the molar mass. So the number of moles are 5 multiplied by 10 to the power 6 million. Then we need to find the molar mass of sodium hydroxide. So let us go to the periodic table. So we know that we are talking about this. So what's the mass number of sodium is 23. Then plus oxygen is basically 16. Then plus hydrogen is 1. So this basically gives us a 40. So 40 is basically the molar mass. So having found 40, we can go back and the place here is 40 grams. Then when we multiply that, it will be 5 multiplied by 40, it will be 200. Multiplied by a million. So we're going to end up with 200 million grams. Then we divide by 1 million to convert it to tons. Then we end up with 200 tons. So 200 tons is the required quantity. So that we say 200 multiplied by 2, it gives us the 400. Okay, so 200 is the required. So C is the correct answer on this question. Question 10. A learner placed 200 grams of calcium carbonate into a conical flask and added 500 centimeter cubic of 1.5 molar dilute hydrochloric acid solution. What would remain in the flask at the end of the chemical reaction? Okay, so what would remain in this conical flask? So for us to know what will remain in this conical flask, we need to know what is happening. So let us write the chemical equation. So we have hydrochloric acid, then we are adding this is aqueous, we are adding a calcium carbonate. See, this is a solid. As you see, these are solid. Then what are we going to get? So when acid react with carbonates, they give salts, carbon dioxide and water. So we are going to get the case where, in this case, this calcium will displace hydrogen in hydrochloric acid. So we're going to get calcium chloride, then plus this will be in this case aqueous, then plus carbon dioxide, which is gas, then plus water, which is liquid. So these will be the product. So now after we know the reaction, we need to balance these. So we know that we have hydrogen one this side, here we have 2 hydrogens. So we need to balance, so we'll put 2, then 2 hydrogen, which is okay. Then but we have 2 chloride this side, also we have 2 chloride, so this is okay. So hydrogen chloride is balanced. Then we have 1 calcium, then carbon dioxide we have 1, oxygen we have 3, this side also have 3, so the equation is balanced. Then let us see what we've been given. So we've been given that the total quantity of calcium carbonate we're adding is 200 grams. So we need to find the number of moles of calcium. So the number of moles of calcium carbonate, which is this one. Then remember, the number of moles is equal to a base mass given divided by the molar mass. So we can go to the periodic table. So we are looking for the molar mass of calcium carbonate. So what we get is, we look for calcium. Calcium is basically is 40. So we have a 40, then plus, then carbon. So we come to carbon. Carbon is here, which is 12. Then oxygen, there are 3 oxygens. So oxygen is 16. So we have plus 3 times 16 because there are 3 oxygens here. Then when we add, we are going to get basically this is 48 plus 12 is 60 plus 40 is 100. So we have 100 grams. So every molar, 1 mole of calcium carbonate has 100 grams. So what we come to do is now we divide what we've been given, which is 200 grams. We divide by 100 grams, we get basically 2 moles. So we have 2 moles of a calcium carbonate. So these 2 moles, remember the ratio is this is 1, so 2 to 1. So when you have 2 moles of hydrochloric acid, we need 1 mole of calcium carbonate. So if you have 2 moles of calcium carbonate, what we require is a 4, so that this balances. Remember this ratio, mole ratio, 2 to 1. So let us see how many moles of hydrochloric acid we have. So we have been given the volume, we have given the molar. Okay, then we know that molar or molarity is given by number of moles. So moles divided by volume. Now volume should be in decimeter cubic, which is liters. So and 1000 centimeter makes up 1 liter, which is the decimeter. So what we have 500. So this means we have basically volume 500 centimeter cubic is equal to x. Then we solve for that. So what we get is we are going to end up with 0.5 this as our volume. So we have molarity. So molarity is 1.5 is equal to moles, then 0.5. Then we cross multiply to find the number of moles. Then the number of moles will be basically equal to 1.5 times 0.5, which is basically equal to 0.75 moles. So for the complete neutralization or complete dilution of this, what we need to happen is we need 4 moles. So for 2 moles of calcium carbonate, we need 4 moles of hydrochloric acid, but we only have 0.75. So what this means, hydrochloric acid will finish first before calcium carbonate finishes. So we are going to remain with part of calcium carbonate in the conic flask. So we are going to have calcium chloride, carbon dioxide will leave because this is open, then water, then a bit of calcium carbonate will remain in this flask. So basically, if you look at the answers, calcium chloride and water on it, no, because part of calcium carbonate will not be used. Aqueous calcium hydroxide on it, not true. Calcium carbonate, aqueous calcium hydroxide, no. Water. So we have calcium carbonate, calcium chloride, which is true, and water. So D is the best answer in this case. We move to question 11. Solution Q reacted with aqueous sodium hydroxide, producing a gas which changed the color of a lead litmus paper. Which of the following could have been solution Q? So we need to identify this gas. So this gas is basically changing the color of the lead litmus paper. So this gas can be basically only ammonia. So this is ammonia gas. So if we want to get ammonia gas, we need to have ammonia in our solution. So this one has no ammonia, no ammonia, no ammonia. So basically what we have is which is ammonium sulfate. Okay, we go to question number 12. Salts can be classified as acidic, basic, neutral. Which of the following is a pair of basic salts only? So what you need to understand is how basic salts are formed. So basic salts are normally formed by a neutralization reaction, where we react a weak acid and a strong base. A weak acid and a strong base. So what we need to know is from here, we need to know which would we have a weak acid here. So also we need to know the strong acid. So strong acid, we have hydrochloric acid, then we have ibromic acid, iodinic acid, then we have basically nitric acid coming down all the way. So now if you look at the options, we have potassium chloride. Okay, so because here we have chloride, this chloride is a strong acid. It cannot be a basic. It can either be acidic or basically neutral or normal. Then also have chloride here. Then we have chloride. So A, B, C, A, B, and D, they have chloride. So these they have got something in common. And what you notice here is, if you understand the base, the salt, this is a normal or neutral salt. Then this is a basic. So A is out. Then what you notice here is, in this case, this one is, it has an H. So this is hydrogen. It can react with water. So this is acidic. Then this one is normal or neutral. Then this is acidic. So basically what you notice here is this is a basic and this is a weak acid, which is calcium acetate made from carboxylic acid, which is a weak acid. So C is the best answer. Number 13, a bee sting is acidic. Which household substance will neutralize a bee sting? So what you notice here in this case, basically we need to have a base plus acid reaction to give us basically salt and water for us to do this. So this is neutralization reaction. So this is the household. So if you see vinegar is acidic, lemon is acidic, so we have damp common salt or damp bicarbonate of soda. So this is the basic. So this is the base that we need to react with acid to get this our outcome. So A is the best answer among the options. Question 14. Choose a statement that is most likely to be true about the elements in group 8 of the periodic table. So these group 8 elements are basically also known as group O elements. So these are single elements. So they, in their molecular formula, they exist as a single element. Why? Because their outer shell has got a full electron. So they're either 2 or 8. They are stable. So let us look at the options. They are equally reactive. No, they are not, because of they have stable, they have full electrons in the outer shell. Form oxide of similar formula? No. Occur and combined in nature. So C is the correct answer. Number 15. which of the following statement is correct about alloys? They are mixtures made up of metals and other substances, which is true. Alloys are mixtures. Compounds are not compounds, but they are just mixtures. So B is not true. Metals that are covalently bonded, no. Covalent bonding mostly occurs under non-metals formed by heavy metals only, no. So this is A is the best answer. Question 16. Choose a fertilizer that contains all the three elements needed by plants for normal growth. So what you notice here is plants need three key elements for growth. So we have number one, nitrogen. For normal growth, nitrogen. So nitrogen is basically for growth. Then we have phosphorus. So phosphorus is for root development. Then we have number three, which is potassium. So potassium is basically for seed formation. Seed formation is one that you see. So these three are the key elements that are needed for plants for normal growth. So we need to look for this. So this one as nitrogen, but no potassium and phosphorus out. Potassium and nitrogen is there, but phosphorus is not here. This one was nitrogen, potassium, and phosphorus. So C is the best answer. Question 17. A gas escaping from a pipe in a chemical plant is tested and found to be alkaline. What is this gas? So if you look at the question, the clue is, one, the key is this is a gas. Number two is an alkaline gas. So an alkaline gas is basically what is it? So we have ammonia. So ammonia is a non-alkaline gas, and basically what it is, it's basically we turn most lead, litmus paper, blue as the test. So you need to know the testing. Okay, so 10 lead, litmus paper, blue. Know that test. Then we go to number 18. Some organic compounds are generally non-reactive due to lack of specific site for chemical attack. Which of the following is such a compound? So we know that this is an organic compound and is non-reactive due to lack of this. So a non-reactive, it means it's saturated. So the saturated compounds, these are alkanes. So alkanes group. So among the answers, we need to look for an alkane group. So we know that A is as a double bond, so this is an alkene. B, there's no double bond, and it has 4 carbons and 10 hydrogens. So this conforms to this formula. So you see this is an alkane. So B is the correct answer. If you look at C, because of this hydroxyl, this is an alcohol. Then this one, because of this hydroxyl and the double bond between oxygen and carbon, this is carboxylic acids. So just to note, you need to note what is special about alkanes. So alkane, basically, they are saturated. Why are they saturated? Because of their single bond. Okay, so their single bond is so strong that they are fairly non-reactive, or they are fairly unreactive. However, these burn in air, so that's why they are used as fuel to provide heat energy. So what happens is, when an alkane burns in oxygen, because of the air is burning in oxygen, it will produce water and carbon dioxide, CO2, water and carbon dioxide. So when in the case where that they are burnt where the air is not enough, they are going to produce a soot because of incomplete combustion, and hence they will produce carbon monoxide. So that should be noted. Number 19. Choose one organic compound that makes up 98% of natural gas. So 98% of natural gas mainly come from methane. So methane is the correct answer. So this is one thing that you should know by heart. Number 20, which of the following structure belong to the same homologous series of compound? So we need to see basically what you see here from here. This is as 3 carbons, then 8 hydrogen. So this is basically an alkane. Then if you see number 2, this is because of this. This is an alcohol because of them the hydroxyl part. Then if you see number 3, so this one doesn't have double bond, they are all single bonds. So we need to just establish the formula. So this is C, 1 2 3 4 5. So there are 5 C's. Then we have how many hydrogen? 1 2 3 4 5 6 7 8 9 12. So this one is basically an alkane, like the first one. Then you look at number 4. So number 4 has a double bond. So this one is an alkane because of the double bond. So what you notice here is, if you are to check here, you notice that 1 and 3 they belong to the same homologous series of compounds. So D is the correct answer in this case. So basically this is how you answer section A to get the optimal marks. Please check out for section B episode where we cover all the questions in section B on our YouTube channel.